Okay, after doing the crossover, we have a certain mutation step called mutation step. Our DNA, even though it is being inherited from our mother and father, we have our certain distinctions from our parents. Actually, that is coming from the mutation of the gene. Okay. So problem of the hill climbing is actually the equal problem of Nazi, right? You just strong driving force in a pursuing goal. Just set up a certain strict rule. If you don't follow it, and then you are not going to keep that thing in your population. You just make it extinct. It's bad. Actually, it's bad. Pretty bad. It's very bad. So, but it's really strong driving force to get to the local minimum. It doesn't see a long-term evolution. It doesn't see this long-term evolution coming up. So hence they eliminate the diversity of population. No starting points for the new ways to improve. It's a new ways to improve, but it's not going to show you that it doesn't going to show you that long time evolution. That's the problem of the hill climbing. Always chasing the bigger solutions. In genetic algorithm, what if we eliminate the diversity of population through the selection and crossover step? We are going to eliminate all the diversities. Means that our solution approach is going to be like this, going to be like this, going to be like this, and it's all going to point the local minimum. Somehow different, but inherently same. If you just eliminate all the diversity, then the society is being stalled. At the end of the day, what we are going to do is play with the selecting parents. But sometimes you need to think out of the box. That's being called the mutation. So you just imagine have a wild guess that why don't we just paint the rabbits with the tiger marks? It's kind of freaky, right? However, if you just keep exchanging the DNA, changing the DNA makes some mutations in our genotype, sometimes it can be a good solution. You can create a superhumans like that. Okay? So in biology, mutation is one cause of producing much stronger viruses. Of course, viruses are bad, but much stronger solutions would be good, right? Much stronger solutions would be super. In that case, we have to do some mutation in our scheme. So mutation method looks like this. These are basics of the mutation step. And simple mutation is just random mutation, right? So if it is a numeric variables, and you just assume a distribution and draw a new random numbers from the distribution. So that's what random number generator does. So you just assume a certain random number generation here. These are original routes, and yeah. Of course, this is going to be pretty invalid solution. You have to repair it. If categorical values, these are our TSP case. In that case, it's also the same. Assume a distribution and draw a category. So rather changing the value directly, you just select this category and this category, and selecting these categories are random selections. And then you just exchange it, right? Don't diverge from the number set of the category value. Yeah, actually these are still the changing the values, but selecting the categories with the random number selections. The swap mutation is the selecting two values, two genes, and swapping the locations like this. And yeah, this is less susceptible to the invalid solutions because that these are valid genes. So if you just swap it, then it is going to be a valid solution. Okay. So remember that this is actually the last step before the solutions are inserted into the population. So there should be no invalid solutions. So you have, if you see this kind of errors in the solution set, means that you have to repair it, repair somehow. Okay. So you need to repair it. Why we need to repair process? So traveling salesman problem, every series should be visited. If a solution is visiting A series, and then you have 1, 2, 3, 4, 5, 6, 7, and 8. Actually, 5 is visited twice, and 8 is not visited. Means that typical infeasible solution. And this is invalid solutions. And we don't want that in our population. Actually, this can happen by random mutation or a crossover from the various approaches. For example, multi-point crossover is often the case of this invalid source of the invalid solutions, and random mutation can be a valid source of these invalid solutions. How to repair this? Random repair until the solution becomes the feasible solutions. You just find some errors and you just insert the random numbers, random categorical numbers, until you hit that solution becomes valid. Okay. Or the other thing is that grid repair with heuristics. Often, what can be done is that you can just lump the another selection, crossover, and mutation step, and you just hope for that you can get the valid solution this time, right? So, but this is just depending on the luck. So, okay, it's not going to be the great approach. Anyhow, one thing that you have to remember is that you have to utilize this repair step. You have to keep this repair step to keep the invalid solutions out of the population, because it doesn't make any sense, that route. Okay. So remember, the repairs is a type of mutation. So if you just find this 2 5s, and okay, I just want to have 1 5 eliminated and put 8 there, then the solution becomes makes sense. However, you are making a random choice here, which 5 to remove and put 8. It's going to be this one or it's going to be this one. So because it's a random choice, this repair is going to be a type of mutation.